When envisioning the apocalypse, our minds typically conjure flames. We envision pandemonium, clamor, and ruin. Yet there's a spot on our globe that resembles a post-apocalyptic scene already unfolded, and it's characterized not by flames but by a profound, stunning, and utter hush. This spot is Antarctica. To observers, it appears as emptiness. It's an expanse of pristine white extending endlessly from one horizon to the other, a landmass of frost bigger than Europe and Australia put together. Isolated at the planet's southern pole, it seems unchanging, it seems lifeless, it seems like a realm where time itself has halted. But this tranquility is misleading. The frost isn't merely a cap, it's a shroud. And under that icy shroud lies a realm as intricate, as fierce, and as enigmatic as anything above ground. Active volcanoes belch smoke in the shadows. Lakes untouched by sunlight for 15 million years exist there. Rivers run counter to gravity, and mountain chains rivaling the Alps lie fully entombed out of view. Concealed within the stone are clues to humanity's history, and possibly a chilling blueprint for what's ahead. We are about to uncover that pale exterior. We are about to venture into the icy sepulchre to discover its depths. To grasp the concealed wonders, we first need to face the obstacle head-on. Antarctica stands as the loftiest, most arid, iciest, and gustiest landmass on the planet. It's a watery wasteland. The frost cover here isn't a mere shell, it's a monumental geological force. On average, the ice layer exceeds 2 kilometers in thickness. In its profoundest depressions, it drops to almost 5 kilometers. That's a profundity surpassing the peaks of many mountains elsewhere. This colossal ice buildup, formed from 34 million years of accumulated snow, weighs immensely. So much so that it has compressed the underlying land. The ice's enormous pressure has forced Antarctica's bedrock hundreds of meters into the planet's mantle. Should the ice disappear abruptly now, the terrain would rebound, though full restoration would span 10,000 years. Scientists term this effect isostatic depression. The landmass is essentially yielding under the aqueous overlay. Yet the ice isn't only burdensome, it's ancient. The atmosphere captured in its lowest strata forms a preserved relic. The particles embedded in its levels hail from long-ago volcanic blasts and cosmic collisions. Traversing the Antarctic plateau's surface is like treading on a chilled archive of planetary chronicles. It feels unyielding, steadfast, and timeless. But as we'll soon discover, the ice isn't a rigid mass. It's dynamic. It shifts, it surges, and at times behemoths stir. The mirage of Antarctica is immobility. We picture the frost as an unchanging edifice, fixed forever. But the ice pulses with life and occasionally rouses. To comprehend the magnitude of this motion, consider one enormous entity called a 23A. It's the planet's biggest iceberg, a behemoth of solidified H2O, tipping the scales at almost 1 trillion tons. Its top spans 4,000 square kilometers, outstripping Rhode Island or doubling Greater London's footprint. For years, this colossus slumbered. It calved from the Filchner-Ronne ice shelf in 1986, amid the lingering Cold War. Yet it stayed put. Its submerged bulk, an underwater ice peak, collided with the ocean bottom. It anchored. For more than 30 years, it lingered immobile, a fixed icy outpost, as the globe evolved nearby. Then in 2020, a change occurred. Maybe the surrounding seas warmed a touch, or the seabed yielded. A 23A lifted free. It started drifting. Today, this trillion-ton specter glides northward on ocean flows, heading for the South Orkney Islands, a ponderous titan, en route to dissolution in milder climes. It underscores that in Antarctica, the terrain itself is fleeting. The solid earth underfoot now could become navigable waves soon. This frost's staggering scale forges a reality hard to fathom. We're dealing with frozen depths reaching over 4 kilometers in spots. This isn't mere insulation. It's a seal. It isolates the land from the skies, the sunlight, and time's flow. Beneath this oppressive load, physical principles shift. The strain at the ice sheet's foundation is so extreme that it reduces water's freezing threshold. This paradox arises from the extremes. Antarctica's surface ranks among the chilliest spots in existence. Yet where the ice presses against the underlying rock, it's damp. That immense pressure causes the ice to thaw from underneath, forming a concealed slick coating. Rather than resting directly on stone, the whole ice mass glides atop a thin veil of liquid. This slick boundary enables the sheet to creep forward, easing off the landmass and spilling into the ocean, acting as a restless, ever-changing cover. It conceals the actual contours of the terrain below, draped in a vast, pale shroud so ponderous it bends the planet's outer shell. But what keeps this ice in place? Why does it endure? The explanation hides in the encircling sea. Antarctica stands as an impregnable stronghold, defended not by rocky barriers but by a watery rampart. Known as the Antarctic Circumpolar Current, it's Earth's mightiest and most expansive marine flow. A relentless loop of frigid water swirls around the land from west to east. Uninterrupted by any shore, it transports 130 million cubic meters of water every second. Functioning like a heat deflector, this stream erects a divide that blocks the milder flows from the Pacific, Atlantic, and Indian Oceans from approaching the pole. For the past 34 million years, it has confined Antarctica in perpetual chill, cutting it off thermally from the broader world. This icy enclosure enforces its own environmental laws within, safeguarding the frozen expanse, the quietude, and the continent's buried enigmas from the heating beyond. It's the trigger for the forest's demise and the onset of the stark hush. Imagine peeling back the frost, dissolving the global cap. The terrain exposed wouldn't be a barren, eroded expanse. Instead, it'd reveal a wild, striking, and lofty domain. Deep in East Antarctica, smothered under the densest section of the ice, there's a chain of peaks that challenges imagination. These are the Gamburtsev Mountains, their spectral remnants. No person's gaze has beheld their crests. No breeze has brushed their heights in 30 million years. Unearthed not by trekkers but by Soviet researchers in the 1950s through seismic probes, they tuned into reverberations from the stone far underneath. Their revelation was breathtaking. Far from a mere ridge, it's an alpine system rivaling Europe's. Summits climb to 3,000 meters, piercing the ice's base. You'll find sheer drops, profound U-shaped gorges etched by long-lost streams, and razor-edged tops that appear freshly hewn. The enigma is their endurance. Typically, glaciers scour peaks smooth into low nubs across eons. Yet here the frost has served as a conservator. It has locked the range in stasis, shielding it from wear like an insect in resin. It's a petrified vista, an untouched cordillera in pitch blackness, bearing an entire land's burden upon its frame. Yet lurking under the ice lurk features far more foreboding than ridges. In the area called Wilkes Land, concealed under miles of solidified H2O, orbital sensors have picked up an oddity. They didn't spot it optically. They sensed it via pull. There's a mask on, a hefty density buildup embedded in the lithosphere. It tugs on the craft as they orbit by. This pull is enormous, suggesting a round formation spanning nearly 300 to 500 kilometers across. This is the Wilkes Land anomaly. The primary hypothesis points to a collision site, but an extraordinary one. Should the analysis hold, it's the remnant of a strike from a space rock 2 or 3 times the scale of the dinosaur wiper. It lingers as a quiet, ringed gash in the foundation, packed solid and veiled by frost. To grasp the ferocity's magnitude, consider the culprit. Likely, a space rock around 30 meters in diameter. The collision would have vibrated the globe, like a chime, and unleashed a quake, potent enough to crack the surface antipodally. Estimates for this possible basin point to about 250 million years old. That figure echoes in any Earth scientist's thoughts. It matches the timeline of the mass extinction, the Permian event mentioned before, when 96% of Earth's species blinked out. Long ago, we pinned it on the Siberian Trap's eruptions. But the Wilkes Land Basin implies a grimmer, intertwined plot. Might this impact have been the spark? Perhaps it pierced the planet's outer shell, jolting the underlying layers with such force that it set off volcanic outbursts on the far side of the world. Antarctica could very well hold the key evidence to unraveling the biggest unsolved puzzle in Earth's past. Proof lies buried, music beneath the planet's iciest shroud, ready for us to bore through and contact the rock that ended an entire era. It's a burial ground concealing the very force that doomed it. Uncovering the concealed water wasn't a sudden revelation. It started as a faint echo in the readings back during the Cold War's peak. In 1964, Soviet scientists towing seismic gear over the vast icy expanses picked up an unusual pattern. Typically, the acoustic pulses they sent into the glacier would return irregular, mirroring the uneven, craggy landscape hidden below. Yet in one enormous zone, close to the coldest point, the echoes shifted. They returned smooth, utterly, inexplicably smooth. For a long time, this seemed like a mere error in the instruments, a blip in the records. Only in 1973, as teams from Britain, the US, and Denmark conducted radar flights above the area, did the truth emerge. The scans pierced the frozen layer and exposed an interface resembling a flawless mirror. It signaled water. A fluid line lay hidden under roughly 4 kilometers of unyielding ice. What they observed wasn't some isolated icy puddle. It was an underground ocean. Meet Lake Vostok, the prized gem of Antarctica's hidden depths. To picture its size, think of Lake Ontario up in North America, but cap it with an icy ceiling 2.5 miles thick. Enormous at 149 miles in length and 31 miles across. It's a reservoir that's been airtight from the outside world for a minimum of 15 million years. The most solitary body of water imaginable. Lake Vostok endures in constant, oppressive blackness. At the water's top, the weight exceeds 350 atmospheres, strong enough to crumple a submersible like empty tin. Still, the water stays unfrozen. The overlying ice's massive squeeze and the subtle geothermal energy seeping from the depths below maintain its liquidity. It's like a warming cover. The glacier serves as an ideal barrier, holding in the Earth's inner heat to keep the liquid hovering right at the edge of solidifying in a fragile, unending equilibrium. Lake Vostok's seclusion has forged a chemical makeup found nowhere else on the globe. As the ice sheet creeps across it, The lowest portions thaw, feeding fresh water into the basin. Yet that ice holds trapped air pockets from eons past. Upon melting, those gases flood into the water. Sealed under intense pressure, they can't rise out. They integrate. Through countless millennia, this has flooded the lake with dissolved gases. Experts figure its waters hold oxygen levels supersaturated, maybe 50 times that of a standard lake. Normally, oxygen fuels living things. But in such overloads, as we explored before, it turns harmful, like a poison. Vostok's depths aren't merely shadowy and frigid. They're an intensely oxygenated, pressurized vat of chemistry. Anything surviving there must evolve to handle environments that would doom typical sea creatures. Life persists stubbornly, though. As researchers bored close to the surface, without piercing it, to prevent pollution, they pulled up chunks of accretion ice, frozen splashes from the lake, clinging to the glacier's underside. Within that, DNA turned up, traces of microbes, tough extremophiles suited to chill and gloom. Certain ones were heat lovers, implying clusters near warm vents on the bottom, drawing nutrients from rocks instead of light. Even odder clues appeared. Genetic bits suggested larger forms, multi-celled beings, molds, even shellfish. One strand resembled a fish parasite's code. This ignited a bold, divisive idea. Fish down below, sightless pale schools gliding through Vostok's endless night, shielded from the surface's glacial upheavals. Answers elude us. The lake stays intact solely in our minds. A locked ecosystem poised for eventual probes to uncover its secrets. The fixation on Lake Vostok goes beyond our world. It's practice, preparation for hunting extraterrestrial biology. Gazing at the solar system, icy satellites catch our eye. Europa, around Jupiter, Enceladus, by Saturn. Frozen exteriors encase deep brine seas, sustained by gravitational pulls. These icy realms resemble Lake Vostok on a massive cosmic level. If organisms can thrive in the frigid, shadowy, high-pressure, oxygen-laden depths of Vostok, sealed away from sunlight for millions of years, then similar life could persist on Europa. Vostok serves as our earthly stand-in, the nearest equivalent to an extraterrestrial sea right here at home. Each breakthrough uncovered in Antarctica's shadowy expanses edges us nearer to resolving whether humanity stands alone amid the stars. The southern continent's frozen expanse acts as a lens peering into the universe's potential wonders. Yet Antarctica brims with paradoxes, and few rival the dramatic spectacle at Mount Erebus. Perched on Ross Island, this peak surges almost 4 kilometers from the icy ocean, marking Earth's southernmost active volcano. It stands as a fiery guardian amid a realm of frost. Erebus has unleashed eruptions non-stop for over 1.3 million years. Far from slumbering, it's vibrant and pulsing. At its crest lies an uncommon geological marvel, one shared by just a few spots worldwide. A ceaselessly swirling lava lake. The scene defies belief. Set against the stark white glaciers and vivid azure polar skies, a steady column of vapor and sulfurous fumes billows from the caldera. During the endless nights of polar winter, the peak emits an ominous crimson glow, casting light beneath the vaporous shroud. It feels like a gateway to the planet's core, a seething vat of phonolite lava, that uncommon molten material laden with feldspar, simmering at 1,000 degrees Celsius, encircled by ice, locked at -50 degrees Celsius. Here unfolds a clash of extremes, where Earth's inner warmth confronts its outer chill. Still, Erebus's real marvel unfolds not at the top, but along its sides. The volcano's escaping warmth doesn't merely dissipate upward, it permeates the stone and clashes with the surrounding ice. This clash births ethereal formations known as fumaroles, towering ice spires reaching 10 meters that release steam into the frigid atmosphere. Beneath them, however, the warmth has sculpted a concealed realm, dissolving intricate webs of caverns straight into the glacier. These are Erebus's ice caves. Venturing inside transports you to an otherworldly domain. The walls consist of sheer blue ice, see-through and shimmering with subdued surface light. The ground might be heated stone or fine volcanic grit. The atmosphere hangs heavy with moisture and fog, shielded from the fierce downslope gales howling mere meters overhead through the ice. It's a concealed refuge shaped by the mountain's exhalations. The contrast in temperatures within these caverns is astonishing. On the mountain's exterior slopes, biting winds can numb skin in moments, but tucked into the warmer zones deep inside, conditions can climb to a comfortable 25 degrees Celsius. A balmy spot amid the globe's iciest terrain. Standing in that cozy gloom, attuned to the patter of dripping meltwater and the sizzle of venting steam, you'd forget your bearings entirely. This isn't a deep freeze, it's more like a steam bath. Such steady warmth fosters a viable niche that's endured for hundreds of thousands of years, utterly detached from the mainland. As we've observed, life abhors emptiness. Wherever warmth and moisture converge, living things emerge. Researchers probing these vapor-filled caverns have detected DNA remnants unlike the basic microbes on the surface snow. They've uncovered thriving mosses, algae, and tiny invertebrates in the steamy, moist obscurity. Yet the genetic breakdowns tease at something even more intriguing. Sequences that don't align perfectly with any cataloged species. This implies Erebus's caverns could harbor a distinct underground biosphere. Flora and fauna shaped by seclusion, tailored to an existence of volcanic vapors and ethereal blue radiance. It raises the chance of intricate organisms in Antarctica that have never glimpsed daylight, beings born of the mountain's depths. Erebus looms as the obvious titan, yet it may merely be the vent for a far vaster operation. In 2017, scientists poring over radar scans of West Antarctica uncovered a shocking find. 91 undetected volcanoes lurking 2 kilometers under the ice sheet, concealed from sight. This renders the West Antarctic Rift System among the planet's mightiest volcanic regions, on par with East Africa's Great Rift Valley. The majority of these peaks lie inactive now, slumbering behemoths pressed beneath the glacial burden. But they're far from extinct. Should they stir, the ripple effects would span the world. A subglacial outburst wouldn't always breach the surface. Rather, it would liquefy the ice's underlayer, forming enormous watery slicks that ease the glide between bedrock and frost. This could dislodge the ice sheet, enabling it to glide more swiftly toward the sea. The heat from underneath serves as a possible trigger for rising oceans, an unpredictable geological factor that might undermine the whole West Antarctic ice sheet, starting from its foundation. The ice isn't solely dissolving due to the hotter atmosphere overhead. Rather, it's perched atop a heating element that could gradually ignite. Antarctic ice represents far more than solidified water. It's preserved history. Snowfall on the elevated plateau doesn't thaw. Instead, it builds up in successive strata, season after season, era after era. The pressure from fresh layers compresses the earlier ones, capturing small air voids amid the crystals. As the snow turns to ice through compaction, these bubbles get locked in eternally, forming minute archives of the planet's atmosphere from the precise instant of their entrapment. Scientists bore into the ice sheet, often exceeding 3 kilometers in depth, to extract cylindrical samples that serve as a chronological record, stacked vertically. Once hauled up and processed in a sealed chamber, the liberated ancient gases bubble and crackle upon release, echoing the breath of bygone eras. We get to inhale the atmosphere from the Roman Empire's time, scrutinize particles from eruptions that shrouded the skies long before human presence, and gauge CO2 concentrations from the previous glacial period. The Vostok ice cores offer an unbroken chronicle of climate spanning 800,000 years, a detailed ledger capturing every heat wave and frost the Earth has weathered. It's an archive crafted from frozen pages inscribed with isotopes and sediments. At the edge of Taylor Glacier, in the McMurdo Dry Valleys, lies a spectacle resembling a gash in the landscape. Amid the dazzling white ice and somber rocks, a profound, blood-like red fluid seeps from the glacier. It taints the surrounding ice in scarlet hues, cascading into the icy Lake Bonny beneath. Known as blood falls, this phenomenon puzzled explorers for years who attributed it to crimson algae. Yet the reality proves even more bizarre. It's oxidation. The emerging liquid originates from a hidden subglacial reservoir sealed under the ice for over 1 million years. This relic body of water is intensely saline, a brine roughly 3 times saltier than seawater, keeping it liquid at temperatures as low as -10 degrees Celsius. Loaded with iron, eroded from underlying rock by the glacier's relentless scrape, the fluid emerges, deprived of oxygen. Upon surfacing and encountering air after eons, it transforms rapidly, oxidizing into rust. Essentially, the glacier weeps iron oxide. But the brine transports more microbial life. These organisms thrive in pitch-black isolation, metabolizing iron and sulfur rather than oxygen, enduring in a frigid, briny vault. Blood Falls opens a window to a vanished biological realm, a vivid crimson beacon from organisms concealed in shadow. Beyond that, Antarctica functions as the planet's premier repository for extraterrestrial relics. The landmass essentially traps incoming celestial debris, like a massive glove. Space rocks plummet to Earth steadily everywhere, but they vanish amid trees or waves. Here, they land on pristine snowfields. A dark stone against the bright ice stands out unmistakably. Yet the ice doesn't merely highlight them. It concentrates the collection. As sheets creep from the continental interior seaward, they transport embedded meteorites along. Encountering obstacles like mountain barriers, the ice decelerates and erodes under harsh, arid gusts. Evaporation exposes the ancient visitors, which concentrate on the ground in concentrated zones. Researchers stroll these azure ice expanses, gathering specimens journeyed from the asteroid belt, lunar origins, or even Mars. Among the key Martian pieces discovered, those suggesting hints of primordial life on the rusty world, were simply lifted from Antarctic surfaces. It's an intriguing irony. The prime spot for examining solar system rocks lies at the southern pole's frozen expanse. It's challenging to picture the Beacon Plateau now as a once vibrant habitat teeming with activity. Yet rewinding 100 million years to the Cretaceous era, would trade today's quiet for the thunder of cascades and animal cries. Antarctica wasn't a frozen block. It anchored the supercontinent Gondwana, linked to Australia and South America, in a sprawling, verdant southern domain. Positioned northward of its current spot, it still lay polar, but Earth's hothouse conditions, lacking polar caps, kept it verdant, dense with forests akin to modern New Zealand or Patagonian woodlands. It featured meandering streams through vales now smothered beneath kilometers of frost. The atmosphere buzzed with pollen and the drone of bugs. This created a polar haven, a verdant expanse at the world's southern edge. Traces of this vanished realm linger in the stone. Along the Antarctic Peninsula and the Transantarctic Mountains, scientists have unearthed fossils that upend our views of the polar zones. Discoveries include leaves from the southern beech tree, Nothofagus, alongside fronds from enormous ferns. Yet the most puzzling find involves root systems. These fossilized roots remain in their original spots right where they once sprouted. This reveals a key truth. These trees didn't arrive via some deluge. They thrived right there. However, existing at the pole posed a distinct obstacle. Despite the warmer climate, Earth's axial tilt ensured the poles endured extended winter nights of complete blackness and summer stretches of non-stop daylight. These became known as polar woodlands. The trees evolved to cope with a daylight pattern unique to that location. They probably entered a state of dormancy over winter, dropping leaves to endure the endless gloom, then burst into rapid expansion under the perpetual summer sun. It formed a woodland of dim light, an ecosystem tuned to an otherworldly pulse of illumination and obscurity that no contemporary tree could recognize. Antarctica's verdant past reached one last intense phase. Roughly 50 million years back in the Eocene epoch, the planet faced a sharp, extreme rise in worldwide heat, called the Paleocene-Eocene thermal maximum. Atmospheric carbon dioxide levels skyrocketed. The globe transformed into a tropical wilderness. In this period, Antarctica's shoreline wasn't merely mild, it turned subtropical. Samples drilled from the ocean floor near Wilkes Land show pollen from palms and spores from macadamia-like flora. Picture a scenery resembling Florida's shores but planted at the South Pole. The seas were balmy, around 20 degrees Celsius, warm enough for a dip. Alligators and reptilian creatures akin to turtles probably lounged along the banks. This marked Earth's ultimate major warm spell, one last extravagant flourish before the gradual chill set in. It stands as a stark warning about how responsive the polar areas are to atmospheric composition. The gap between an ice cover and palm groves boils down to merely a few hundred parts per million of CO2. If we see Antarctica as a landmass stronghold, a snowy bastion shielded by ocean flows and frigid air, we should also admit that all strongholds have an entryway. Every safeguard has a weak link. For this southern land, that vulnerability sits along the isolated shores of West Antarctica, draining into the stormy depths of the Amundsen Sea. It manifests as one enormous ice stream, dubbed the Thwaites Glacier by ice experts. Yet in quiet talks among researchers and global news flashes, it bears a graver, more ominous label. It's termed the Doomsday Glacier. This moniker stems not from hype or alarmism, but from stark physical realities. To appreciate its critical role, we need to comprehend its magnitude first. Thwaites defies typical glacier images. It's no scenic icy stream meandering through peaks. Instead, it's a behemoth. This icy stretch spans about the area of the UK or Florida. Its front measures more than 120 kilometers across. It forms a turbulent, towering barrier of snow above the waves, plunging thousands of feet beneath them. So immense that aerial views reveal endless splintered ice across the skyline. But its immensity isn't what sparks dread. The dread arises from its purpose. Thwaites serves as a linchpin. In old building designs, the linchpin is the wedge at an arch's crown, the element securing the rest. It supports the whole framework's load. Pull out the linchpin, and the arch doesn't merely droop, it crumbles. Thwaites fulfills this precise duty for the West Antarctic ice sheet. It functions like a stopper in a flask. Uphill from it, pressing with billions of tons of force, stretches a huge, submerged trough of land ice already below sea level. For millennia, Thwaites has acted as the dam. Its broad, hefty front has anchored this ice body, scraping the seabed and stanching the advance. But that dam is now giving way. Radar from orbiting satellites exposes a scene of distress. Thwaites' top is fracturing, far from the uniform slab it once was. Enormous fissures, stretching miles long, radiate over the ice shelf like cracks in shattered glass. The glacier speeds up, surging quicker toward the ocean, pulling taut and wearing thin from its own strain. We're witnessing the planet's utmost fragile spot. It's the fragile strand that, if tugged, could undo the shorelines of every landmass worldwide. This ancient watchpost has held firm for thousands of years. Yet now it's starting to give way. Viewed from above in a reconnaissance aircraft, the glacier appears unbreakable, immense, pristine, and timeless. However, the real threat isn't airborne. It doesn't stem from gusts or sunlight. The downfall of Thwaites is unfolding in obscurity, deep below the ocean's surface by hundreds of meters, in a realm beyond human sight. It's an assault launched from underneath. To grasp this unseen conflict, we must first examine the structure of the ocean bed. Typically, glaciers rest on terrain that rises toward the interior. Resembling an incline, when the ice pulls back, it shifts onto elevated, less submerged areas, which inherently curbs its pace and allows it to steady. But Thwaites occupies a reverse incline. The underlying rock forms an enormous sunken basin. Heading farther inland, the elevation doesn't climb, it descends. It sinks progressively lower, dropping kilometers below sea level toward the continent's core. This configuration is a natural snare, forged by evolving atmospheric currents and fluctuating weather patterns. A particular stratum of seawater has started infiltrating this snare, known as circumpolar deep water. It's briny, compact, and, most alarmingly, relatively warm. It advances across the continental ledge, ponderous and unyielding, slipping beneath the glacier's overhanging platform. It penetrates the void, that shadowy gap between the ice and the bedrock. Functioning like a welding torch, this water targets the grounding zone, the vital tether where the ice clings to the bottom. Rather than softening the ice gradually, it erodes it fiercely. It gouges out enormous, vault-like hollows in the glacier's underside, forming swirling passages that invite additional heated currents to surge forward. With the grounding zone eroding, it gets compelled to withdraw upslope into profounder depths. Here's where the dynamics work to our disadvantage. Greater depth means a loftier ice front. A higher front presents a broader expanse to the warming currents, accelerating the dissolution, which drives the zone even farther into intenser submersion. This creates an amplifying cycle of devastation. Once the pullback initiates along that declivity, nothing resists its momentum. The sea isn't merely dissolving the glacier, it's prying it loose from the ground, peeling back the land from within. The figures from this isolated edge aren't mere statistics, they're a ticking clock. Thwaites is disgorging 50 billion tons of ice annually into the waters. Picture a block of ice 1 kilometer on each side. Now envision 50 such blocks tumbling oceanward in succession, year upon year. This one glacier already accounts for 4% of worldwide sea level increase. Yet it's not the present velocity that alarms experts, it's the speed up. Ice depletion has intensified twofold over the past 3 decades. We confirm this through devices dispatched to unreachable zones. Lately, self-guided yellow submersibles have been deployed via drilled shafts in the ice, plunging into the inky abyss under the glacier. These probes have charted the seabed and delivered a chilling revelation. Scored into the silt are striations, countless aligned furrows in the seabed. These are traces. They record former stances of the grounding zone, etched by tidal forces raising and lowering the ponderous ice during its withdrawal. These ghostly grooves narrate episodes of swift surges. They indicate that within the prior 200 years, Thwaites broke free from a buttressing crest and surged rearward at more than 2 kilometers annually, twice today's rate. This evidentiary trace confirms the glacier's potential for abrupt, ferocious retreats. And on the surface now, indicators of the impending rupture emerge. The projecting ice shelf, serving as the glacier's restraining harness, is fragmenting. Enormous cracks, webbing out like fissures on a shattered pane, are converging. Should this buoyant barrier disintegrate, plausibly in the coming 10 years, the restraining force will vanish, unleashing the inland ice's full mass to hasten seaward. What makes the destiny of this particular glacier in a distant Antarctic outpost relevant globally? The key is the snare's layout. Thwaites isn't a solitary ice stream. It functions as the stopper in the vial. In its rear, bearing down with the amassed burden of eons of accumulated snow, sprawls the entirety of the West Antarctic ice sheet. This colossal ice reservoir holds sufficient volume to elevate oceans by over 3 meters, almost 10 feet. Right now, the Thwaites Glacier serves as a crucial barrier. The drag from its base against the ocean floor keeps this enormous ice reserve stable. Yet should Thwaites give way, like pulling out a stopper, there's no longer anything to restrain the surge. Nearby glaciers such as Pine Island, Thwaites, Pope, Smith, and Kohler would then start to falter as well. This would spark a chain reaction, a domino cascade on a global scale, where one failure sets off the downfall of others. The dynamics of such a breakdown point to a dire outcome that experts call marine ice cliff instability. Ice might seem solid, but it has breaking points. A cliff can only grow so tall before its own mass causes it to crumble. As Thwaites' edge pulls back toward the deep inland trough, the glacier's leading wall will rise higher and higher, surpassing 100 meters over the sea surface. At that point, ice mechanics break down. The sheer wall turns fragile. It won't simply thaw away. It'll fracture. Enormous chunks will break loose due to gravity tumbling into the sea. But that's the cruel part. Each collapse reveals a fresh, steeper face behind it, even more prone to failure. That new surface then buckles, unveiling yet another. It turns into an accelerating ice avalanche, a self-perpetuating breakdown that carves deep into the continent's core. regardless of atmospheric heat, beyond any human control. This process transforms a steady shoreline into a drowned planet, not across millennia, but possibly in just a handful of generations. The stopper is starting to slip, with enormous force mounting in its wake. The danger to Antarctica isn't solely from hotter skies or climbing oceans. It stems from another form of strain: human craving. Under the ice's overwhelming burden, and even further down in the sediment layers of the continental shelf, hides a revelation that shifts this untouched expanse into a prize worth pursuing. Antarctica isn't merely a zone for research. It's a treasure trove, and within, it lingers the echo of the verdant past we mentioned before. The dense forests of Gondwana, the fern-filled marshes of the Eocene, the vast algal mats from Cretaceous seas, all that once vibrant biology, grew, perished, settled, and got entombed. Through eons of geologic pressure and warmth, Earth's forces refined that lost life into oil. Subtle, seismic explorations, frequently masked as pure science, have scanned the shelves off the Ross Sea and Weddell Sea. Echoes from those probes revealed clear signs of huge sediment deposits, the telltale setup for petroleum. The projections remain speculative, yet they're breathtaking. Russian assessments point to up to 511 billion barrels of oil, plus vast volumes of natural gas trapped under the southern seas. To grasp the scale, this stash outstrips the North Sea's leftovers and matches the giants of the Middle East. It's Earth's final major untapped fuel jackpot. A bitter paradox lurks in those strata. The fossil fuels driving the ice's melt are stockpiled in huge amounts right below. The ice cap's a cache of allure. We're consuming relics of the dead to heat our world, and that act prize open access to consume far more. The riches sit there, thick and fluid, poised for the glaciers to pull back slightly and allow the rigs to drill. For now, this shadowy bounty stays sealed not by tech or the frost alone, but by a simple document. The Antarctic Treaty, inked in 1959 amid Cold War tensions, stands as one of humanity's boldest diplomatic feats. It set aside a whole continent, 10% of the planet's dry land, for harmony and discovery, prohibiting warfare and atomic trials. The real safeguard for the trove arrived afterward via the 1991 Madrid Protocol. That agreement, outright, forbids all resource digging and extraction across Antarctica. It made the land a worldwide reserve, shielded by law from the conflicts that have scarred everywhere else. Yet, pacts aren't unbreakable forces of nature. They're deals among countries, and countries evolve. Alliances shift as supplies shrink. The Madrid Protocol includes a provision that darkens Antarctica's outlook. Come 2048, the no-mining rule faces possible reassessment. That year casts a foreboding pall across the frozen realm. It's the deadline for the quiet to end. Should the world face an energy crisis by 2048, with accessible oil reserves depleted and the retreating ice making extraction viable through advanced tech, the urge to shatter the restrictions will be overwhelming. Countries are already jockeying for position, eyes fixed on the timeline, anticipating the point when unity crumbles and the protected reserve risks, turning into a vast mining site. Only the treaty's signature separates the untouched expanse from mechanical exploitation. The struggle over Antarctica's destiny didn't kick off with battleships or explosions. It began with construction. Throughout the land, along ice shelf borders and far into the icy core, countries are erecting facilities, dubbed research outposts. These are genuinely occupied by researchers conducting crucial studies in climate and ecosystems. Yet, in strategic terms, they function as emblems embedded in the frost. A station's placement is always deliberate, a bold assertion of territory, a lasting mark declaring, "This spot is ours and we're staying." We're in the midst of a quiet, frozen conflict, a strategic maneuver waged via supply chains, cement, and metal frameworks. Major nations are enhancing their airstrips to accommodate massive troop carriers. They're assembling fresh squadrons of atomic-fueled icebreakers designed to plow through the densest frozen barriers for constant entry. They're setting up satellite relays with double roles, monitoring environmental stats for research and directing weaponry for defense. China is swiftly broadening its foothold, constructing additional outposts in the mineral-abundant zones of the Australian Antarctic territory. Russia, known for staking a titanium emblem on the Arctic seafloor, keeps a robust ongoing presence down south. The United States oversees the enormous McMurdo facility, a key logistics center serving as the main entry point to the region. All sides keep tabs on one another. They're surveying ocean floors with sound waves, assessing glacial firmness, and braving endless polar nights, not merely to gather info, but to assert control. They're guaranteeing that during the treaty's re-evaluation, they'll be the ones in command of the entrance. The frost is no longer merely an obstacle, it's the game board, and the players are advancing. While this power play unfolds above, the region's ecosystems are evolving independently. Antarctica often evokes a stark landscape of whites and blues. Yet with rising worldwide heat, it's starting to shift hues. It's acquiring a tint of green. This isn't the resurgence of prehistoric woodlands, not quite yet. It's an influx at the cellular level. Images from orbit and on-site surveys indicate that huge coastal snow expanses are developing a lively, mushy emerald shade. That's due to snow algae. For ages, these tiny organisms have subsisted in the snowpack in sparse, hidden states. But warmer atmospheres and more liquid runoff are spurring their proliferation. They're surging in numbers, creating dense organic layers detectable even from afar. And along the stony headlands, ancient moss colonies, among the planet's eldest flora, are expanding faster than at any time in millennia. At first glance, this could seem like nature adapting, a hopeful indicator of endurance. However, in the dynamics of frozen terrain, green spells trouble. Bright snow bounces back solar rays, aiding global cooling, but green algae soaks them up, trapping warmth. By dimming the snow's surface, these outbreaks are reducing the area's reflectivity. They're directly fueling the thaw of the underlying glacier. The southward greening isn't renewal, it's injury. It's a vicious cycle where organisms hasten the demise of their own icy foundation. The land feels fevered, and the verdant patches on its surface signal the internal temperature spike. The coastal color change is striking, but the real emergency lies in the sheer volume. Over the past 5,000 years, Antarctic glaciers held a balanced state. Precipitation accumulated, ice shifted, and chunks calved into the sea, yet gains equaled losses. The region remained steady, a colossal entity at rest, its form subtly expanding and contracting like measured respiration. In recent years, though, that rhythm has turned labored. We're observing a profound alteration in the core mechanics of the area. Ice loss isn't just rising, it's surging at an explosive pace. Orbital mass sensors indicate the continent is shedding weight at levels unimaginable 50 years back. Back in the 1990s, the drain was noticeable. Now it's a flood, We're watching the disintegration of glacial platforms that endured since the close of the prior glacial period. The velocity of this transformation is the scariest element. In Earth sciences, processes unfold gradually. Mountains build up across millions of years. Canyons form through endless ages. Yet the ice responds on a timescale we humans can grasp. It's transforming quicker than we can revise our charts. Fresh water pours from the landmass in vast quantities. Each year, billions of tons transition from the rigid form of the ice cap to the turbulent flow of the seas. No longer a mere trickle. It's a flood of biblical proportions. The colossal entity has stirred, sloughing off its mass with a ferocity that could reshape global shorelines. The deepest mystery of Antarctica isn't solely the secrets buried under the frost, but the destination of that frost once it thaws. In everyday headlines, we discuss rising seas in tiny units, centimeters or inches, figures that feel abstract and far off. Issues for generations ahead. But Antarctica works with far grander calculations. It functions at an Earth-wide magnitude. Trapped inside the icy stronghold of this southern land sits roughly 30 million cubic kilometers of pure water. Should we unleash an accelerating greenhouse spiral that dissolves the whole Antarctic ice mass, the outcome wouldn't be a subtle increase. It would unleash a cataclysmic surge. This isn't some speculative simulation. It's a straightforward assessment of sheer volume. Should Antarctica fully liquefy, worldwide ocean levels would climb by almost 70 meters, over 200 feet. Such a 70-meter surge wouldn't merely alter boundaries. It would obliterate countries. Picture Florida's peninsula vanished, left as scattered limestone outcrops. The Netherlands fades into legend. Vital river mouths sustaining populations, the Mekong, the Nile, the Ganges, submerged entirely. Urban centers like London, New York, Shanghai, Mumbai, and Istanbul sink under dozens of meters of briny waves. Their towering structures transform into habitats for emerging marine life. Shores everywhere would pull back inland by hundreds of kilometers, uprooting billions and wiping out the lush valleys where societies first took root. Antarctica grips the fate of our world's landscapes like a loaded weapon, with rising temperatures pulling the trigger. Each tiny increment of heat applies pressure, unleashing H2O that's remained securely isolated from the seas for 30 million years. Yet thawing ice liberates far more than liquid and vapors. Ice serves as nature's ultimate preserver. It acts like a deep-freeze vault, encasing whatever tumbles in and halting the processes of rot. Buried in the Antarctic permafrost and age-old glaciers lie living organisms dormant for thousands, even millions of years. They're not extinct, just paused. They persist in cryptobiosis, a form of suspended life where their vital processes nearly cease. Their genetic material shielded by the chill, poised for the cue to revive. That cue is warmth. The dread of these reanimated microbes isn't fantasy. It's grounded in evidence. Back in 2014, researchers in Siberia brought back to life a massive virus named Pithorus sibericum from a 30,000-year-old permafrost sample. This behemoth pathogen, large enough to spot with a basic microscope, hails from an epoch when mammoths roamed the frozen plains. Once defrosted in the laboratory, it sprang into action, destroying amoebas on contact. It had endured 30,000 years of cold with its deadly capabilities unscathed. Then in 2016, on Russia's Yamal Peninsula, a spell of extreme heat exposed a reindeer corpse felled by anthrax some 75 years prior. Spores from the thawed ground sprang back to virulence, sickening nearby livestock and sending people to hospitals. It served as a stark alert. The frost harbors illnesses we've long dismissed. In Antarctica, the ice layers run deeper and older than anywhere in the Arctic. It preserves ecosystems from times predating humanity. The worry extends beyond familiar threats like anthrax or smallpox to unknown biological agents, viruses and microbes unseen by contemporary research. These are invaders, tailored to prey on life forms from the Eocene or Pleistocene epochs. As melt flows into the seas and rises as vapor, it might transport these ancient invaders along. The stark truth is our defenses rely on historical exposure. We've adapted alongside certain illnesses. But against these prehistoric foes, we're immunologically untested. The dissolution of the cryosphere isn't merely a water crisis. It risks unleashing a microbial archive sealed for eternity. Confronting the alarming pace of thaw and the apocalyptic fallout of neglect, people are now pondering the radical. If curbing atmospheric heat via policy or finance proves impossible, maybe we could redesign the Earth outright. Enter geoengineering. Large-scale, intentional, and urgent alterations to the planet's natural processes. Once dismissed as eccentric or futuristic fantasy, this idea is now debated in prestigious academic circles and governmental forums as a vital last resort measure. Researchers and technicians are outlining enormous initiatives to protect the vital ice formations physically. Among the boldest proposals is constructing enormous submerged barriers or seawalls encircling critical glaciers such as Thwaites. Rather than halting the waves, these would serve as insulating shields, preventing heated underwater flows from eroding the bases where ice meets rock. Picture a barrier on the scale of China's Great Wall, assembled by automated machines along the shadowy, icy depths of Antarctica's shoreline. Some experts turn their gaze upward. Suggestions include dispersing enormous plumes of sunlight-reflecting sulfate particles high into the polar stratosphere. This approach would replicate a massive volcanic blast, forming an atmospheric veil that reduces solar intensity and induces artificial chilling. There are also ideas for orbiting vast arrays of mirrors to redirect sunlight away from Earth altogether. These notions stem from sheer urgency. They pose huge dangers of unforeseen fallout, potentially disrupting the world's climate mechanisms in unforeseen and chaotic manners. Yet their rigorous simulation in scientific studies underscores the gravity of our crisis. We've arrived at a juncture where tampering with Earth's core climate controls seems essential to avert the rising floods from the southern pole. To grasp the ferocity of the thawing, there's no need to rely on predictive simulations. Consider the Brunt ice shelf right now. This vast protruding slab of the continent, extending into the Weddell Sea, has turned into the backdrop for one of the 21st century's most striking geological spectacles. For decades, experts monitored a fissure called Chasm 1, a long, dormant split in the ice, idle for 35 years like a hushed seismic line. But in 2012, it stirred to life. Remote sensing revealed the rift starting to extend. It advanced like a deliberate, serrated flash, ripping across the surface at several kilometers annually. It pursued its path unyieldingly toward the Halley 6 research outpost, a cutting-edge UK facility perched on adjustable ski-like supports. The outpost was engineered for mobility, yet the rift pressed on without mercy. In an act of urgent ingenuity, The whole structure was dragged 23 kilometers over the icy expanse to escape, abandoning the fracturing terrain below. Then came the unavoidable climax, in early 2021 and once more in 2023. The pressure peaked beyond endurance. The ice groaned in protest. A barrage-like roar reverberated over the expanse as the fissure, at last, breached the surface to the ocean. An iceberg, comparable to Greater London, or twice the size of New York City, carved off in a flash. This wasn't a gentle separation. It marked the emergence of a colossal force. Trillions of tons of frozen mass shifted and collided, producing tremors felt across the globe. It served as a stark alert that Antarctica's boundaries aren't fixed on paper, but sculpted from ice, and those outlines are being aggressively and permanently reshaped in real time. We must acknowledge that the ice's disappearance threatens far more than shorelines, urban areas, or wildlife habitats. It erases history itself. Antarctica transcends mere landmass. It's Earth's archival vault. Over 34 million years, it has functioned as a frigid, unalterable archive of the world's story. Each snowfall layer has captured atmospheric traces, ash from eruptions, cosmic ray imprints, and orbital variations. The ice provides our sole detailed chronicle of planetary patterns across vast epochs. It's the key to unlocking climate secrets. As glaciers dissolve and plunge into the waves, this archive is irretrievably lost. When an iceberg thaws, the ancient air pockets within. Echoes from forgotten eras burst and dissipate into today's breezes. Sedimentary strata mix and settle into the depths. This amounts to a kind of planetary forgetfulness. We're incinerating the archive precisely when we've begun deciphering its contents. Should the ice vanish, we forfeit the framework for our reality. We surrender the reference point. Humanity will chart an unstable tomorrow without historical charts piloting our world adrift, after obliterating the navigational records of the past million years. The catastrophe extends beyond ecology. It's an assault on knowledge. We're formatting the storage before securing the files. Atop the elevated polar expanse, encircled by an endless vista of stark whiteness, reaching every horizon, Antarctica seems impregnable. It appears as the Earth's most enduring element, an icy bastion impervious to change. A landmass that has stepped away from the turmoil of life's timeline. Yet this illusion of endurance is a risky deception, born from the brevity of our own existence. From the viewpoint of a geologist or the planet's climate, the ice cover appears remarkably vulnerable. It stands as a fleeting formation, sustained by a fragile equilibrium of temperatures and sea flows. We're gradually realizing that the southern bastion possesses a vulnerable core. No enormous global upheaval is required to shatter it. Just a handful of degrees. The ice expanse essentially remains a remnant of chillier eras, persisting amid rising warmth solely through its inherent cold momentum. It's a colossal figure, balanced on unstable foundations. Due to its extreme chill and immense bulk, it generates its own climate shield. But should that barrier fail, should the atmosphere heat sufficiently to form surface pools of meltwater, or the seas warm to erode its underside, the downfall turns irreversible. The fissures extending over the ice shelves, the hastening advance of glaciers, the patches of green staining the snow, these aren't mere coincidences. They signal the quakes in an intricate network being driven beyond its limits. We frequently discuss preserving the ice, yet the ice remains unmoved by our emotions. It follows solely the principles of heat dynamics. The vast white entity isn't perishing like a living thing. It's evolving. It's pursuing a fresh balance, unconcerned with our preparedness for the floods it will unleash. The reliability we've assumed throughout human history is drawing to a close, exposing that the southern terrain was never as firm as we believed. It was merely frozen liquid, awaiting the warmth's resurgence. In essence, Antarctica's tale isn't one of domination. It's a chronicle of recurring patterns. The land was verdant once, then blanketed in white and maybe in millions of years ahead, far beyond when our legacies vanish. It will bloom green anew. The international maneuvering, the metal markers staked into the ocean floor, the desperate quest for petroleum, the tense projections of thaw speeds, all these are superficial clamor atop a profound, unhurried truth. Our drive is swift, the ice methodical, yet over time, the ice prevails. Whether by pulverizing our structures beneath its mass or submerging them in swelling tides. Eventually the engines will cease, be it from our departure, upheld agreements, or surroundings too severe for habitation. The clamor of human influence will subside. Once the power units at the South Pole shut down, quiet will reclaim the space almost instantly. The ceaseless wind will set to work at once, entombing outposts under layers of firm white powder. Advancing ice will rend airstrips and demolish facilities, pulverizing metal and stone into grit and sweeping it into the southern seas. The ice will erase our traces. The land will revert to its primal form. It will embrace the hush, a hush that has prevailed for 34 million years, a profound icy majestic expanse that predated our observations and will outlast our absence. So as you rest in the comfort and security of your bedding, allow your thoughts to journey southward. Let them glide beyond urban sprawls, beyond woodlands, across the turbulent, shadowed waves of the Southern Ocean, to the planet's southernmost edge. Picture yourself atop the elevated polar plain beneath an unending star-strewn sky. No noise exists save the breeze sculpting the ice. No motion but the gradual, unseen creep of glaciers toward the waves. It's a realm of utter calm, an interlude in the world's restless pulse. The enigmas of lakes hidden under the ice, the heat from concealed volcanoes, the shades of submerged ranges, all lie protected under the frigid veil. The planet guards its recollections closely, sealing them in icy shadows where disturbance cannot reach. You may now set aside the inquiries. You can surrender the urge to understand, to venture, to fret over what lies ahead. The behemoth slumbers and the earth revolves steadily in the serene gloom. The ice maintains its vigil. You are secure. Good night.